Hey everybody, Mr. Gajewski here, and today we're going to be talking about Lesson 8.4, Similar Solids. Similar solids are solids that have the same shape and proportional corresponding dimensions. Now in this video, I will be doing the problems in the lesson, these problems down below. If you need more help, please read the examples in this lesson. Now over to the document camera. So I'm going to do number 1 and 2. Then I'll also jump ahead and do 3 and 5 from this lesson. All right, so the first one is asking me, are these cylinders similar? Okay, so I'm going to set up a proportion. So in this case, I'm going to do 4 to 6. That simplifies to 2/3. Then I'm going to do 4.5 over 7.5. I can divide both of these by 1.5. 1.5 goes into 4 3 times. 1.5 goes into 7.5 5 times. So I have 3/5 and 2/3. Well, 3/5 does not equal 2/3. These are not proportional. If these were equal, then we would say yes, they are proportional. The next section asks us to find the missing dimensions, assuming that these are similar. So the tip I'm going to give you here is you're always going to want the unknown dimension in the numerator. So if I have my unknown dimensions over here on the right, I'm going to make sure that I write 8 and its corresponding side 20 here. And I'm going to set that equal to W over 8. And really all I have here is a little equation, nice little one-stepper. I'm going to go ahead and I'm going to multiply by 8 on both sides. That'll give me 64 over 20 is equal to W. 64 over 20, go ahead and punch that into your calculator. We get 3.2. Okay, so the width here is 3.2. I'm going to go ahead and do the same thing to find the length. So if I want length in the numerator, let's put L over 11. And if I put the smaller dimensions, so the dimensions from the smaller prism in the numerator, I'm going to have to put the smaller dimension in the numerator as well over here. So I'm going to have 8 over what corresponds with 8, 20. L over 11 is equal to 8 over 20. Go ahead and solve for L. L divided by 11. I'm going to do the opposite of dividing, which is multiplying both sides by 11. L equals 88 over 20. Go ahead and punch 88 over 20 into your calculator. And we're going to get 4.4. So the missing length here is 4.4. All right, we're going to jump back to the book here real quick. So these surface areas of similar solids, when two solids are similar, the ratio of their surface area is equal to the square of the ratio of their corresponding linear measures. So examples of linear measures: length, width, height, radius. Those are all linear dimensions, okay? So we're going to take the radius and the radius, for example, write that as a ratio and square it. When I do that, that ratio squared will be equal to the areas as a ratio. So let's go ahead and let's take a look at this example here, 3. The solids are similar. Find the surface area of the red solid. Round your answer to the nearest tenth. So again, if I'm trying to find the surface area of the red, when I write my ratio, I want to start by writing S, which is the unknown surface area, in the numerator. So again, S equals, so the unknown surface area over the known surface area, which is 608, is equal to the ratio of the linear dimensions squared, square units. We're talking about area here. So 5 over 8, and we're going to square it. Well, S over 608 is equal to 25 over 64. All I did there was square the numerator, square the denominator. I want to get S by itself, S divided by 608, so I'm going to multiply by 608. S equals, well, 25 times 608 divided by 64. I get 237.5. Okay, my units here, I'm talking surface area, is going to be meters squared. We're going to flip back to the book and talk about volume real quickly. Volume is very similar. When two solids are similar, the ratio of their volumes is equal to the cube of the ratio of their corresponding linear measures. So again, volume of red, or volume of A, over volume of B is equal to the ratio of the linear dimensions cubed. So surface area, we square it. Volume, we're going to cube it. If I look at number 5 here, the solids are similar. Find the volume of the red solid. Round your answer to the nearest tenth. We'll jump back to the document camera. So I know that these two cones are similar. So the volume of the unknown, that's V, over the volume of the known, 288, is going to be equal to the ratio of the linear dimensions, or linear measures, cubed because we're talking about, again, volume. So V equals 288 over, well, 5 cubed is going to give me 125, and 12 cubed is going to give me 1,728. All right, from here I have a nice little one-stepper. So volume divided by 288, the opposite of dividing is going to be multiplying. So we're going to multiply both sides by 288. So 125 times 288 divided by 1,728, and we get 20.8. We're talking centimeters, and we're talking volume, so that will be cubed. That is it for today. If you have any questions, please let me know. And as always, like and subscribe. Have a good one.